All right, guys, so today we are going to do at least the vocabulary, all right, for section 4.4 and 4.5. And as you can see on this front page, I mean, there's a lot of them and they're dense, all right? But the descriptions, like the title of them, are actually very informative, all right? So I think that once we get rolling, they're going to make sense. But the key today, all right, very, very important, is that today we are specifically looking at triangles, all right? And what we're doing is we're trying to prove triangles as congruent, right? So let's just talk about what we did yesterday. So what we did yesterday is we talked about how to prove polygons as congruent, right? And what I said yesterday is like, okay, so you're going to have to, in order to prove polygons as congruent, you would have to prove all the sides congruent and all the angles congruent, right? That's what you'd have to do to prove polygons as congruent. But for triangles, we actually have 5 different shortcuts, all right? And those shortcuts are going to be indicative, all right, based off of the title of that definition, okay? So the first one, and again, I have them all written out, so of course you guys are going to have to pause this, all right, and write them out on your own. But if we look at the first one, all right, it's called side congruency theorem, and we use the abbreviation SSS, all right? So that's going to be side. So this one says, though, all right, if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent, okay? So let's draw this out, okay? So here's what I want us to do. We're actually going to make a triangle. Make it small, all right? Because what we're going to do is we're going to then copy and paste that triangle right below it, okay? But even then after that, in order to do, to save some time, all right, let's go ahead and copy and paste these 2, and you're going to put them into the next 3 boxes. So the first 4, all right, should have these. Okay. So let's kind of review, all right, what this side congruency theorem says again. All right, so it says if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. So what I'm going to do is, what this definition is saying is if I could prove that this side of this triangle is congruent to this side, the corresponding side, and then I have this side, all right, congruent to this side, and then that bottom base is congruent to that bottom base, okay? If I could prove all 3 sides are congruent, then I can state that those 2 triangles are congruent, right? So rather than having to prove all 3 sides and all 3 angles, all I would have to do is to prove all 3 sides are congruent. Okay, so that's the first one, side, all right? Now the next one is side, angle, side. And the way that we write it, like the order of it is actually significant. So it's side, angle, side, all right? So we use SAS, all right, or a little SAS, all right, in order to prove this triangle is congruent, okay? So this one says if 2 sides of one triangle are congruent to 2 sides of another triangle, okay? So let's actually mark that. So let's have, let's say that this side is congruent to this side. And then that shorter side is congruent to this shorter side. Okay, so that's the first part of this theorem. And then it says, and the included angles are congruent. So this is the new part here, all right? This idea of an included angle, okay? And so what an included angle is it's the angle that's in between those 2 sides, right? So I would have to prove that this angle is congruent to this angle, okay? That's the included, so this angle is included in between those 2 sides. We could not prove, all right, that this angle is congruent to this angle because those angles are not in between those 2 sides, all right? Has to be the included angle, all right? Okay, so that's side, angle, side, a little SAS, all right, 2 sides, and then that included angle, okay? All right, now the next one is angle, side, angle, all right, so ASA, okay? So this one states if 2 angles in an included side of one triangle are congruent to 2 angles in an included side of a second triangle, all right? So let's look at this one. So let's go ahead and mark, all right, two angles. So let's have the, whoopsie, all right. Let's have that this angle is congruent to this angle. And then this right-hand angle is congruent to this right-hand angle, okay? So that's the first part. So we have two angles that are congruent to one another. And then it says it's an included side, right? So again, it's this idea of it's the side that's right in between those two angles, okay? So it has to be this bottom base here. And again, the way that we write angle, side, angle, all right? Again, it's angle, all right, angle, side, angle, all right? So that side has to be in between, all right, those two angles. So if we can prove, all right, that those two angles and an included side are congruent, then we would have enough information to state, all right, that those two triangles are congruent. Okay, next one, what we have here is angle, side, so AAS, all right? So if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of a second triangle, then the triangles are congruent. All right, so again, the way that we're starting this one is with two angles that are congruent. So this time, let's have this angle is this angle is congruent to this angle. And then this top angle is congruent to the top angle of the second triangle. And so we actually have an option here, all right? It has to be corresponding sides, but the only side that it cannot be is this side this side right here, because that would be the included side, right? That would be the side that is in between those two angles. So what I'm going to do is I'm going to mark this bottom base congruent to this bottom base, all right? You could have also said that this side here is congruent to this side, all right? Either one works because both of those are not the included angle. So that's angle, side. Now, the last one says in right triangles. So the reason why I didn't have you guys draw, all right, or copy and paste those two triangles in this bottom one is this one is specific about right triangles. So I'm going to make a right triangle. All right, I'm going to mark my right angle. And then I'm going to copy and paste that and put it right beside it. Okay, so those are my two triangles. So in this one, it says in right triangles, if a hypotenuse and a leg of one triangle are congruent to a hypotenuse and a leg of a second triangle, then the triangles are congruent. So real quick, we just have to talk about which one's our hypotenuse, right? So if we look here, your hypotenuse is always going to be opposite of that right angle. So I'm going to mark these two sides right here as congruent. Those are my hypotenuse. And then from there, you have two legs, all right? So the legs of a right triangle are the other two legs, all right, or the other two sides. And so you could mark this side congruent to this side, all right? So hypotenuse leg, all right, would be another way of proving these two triangles as congruent. Okay, so I'm going to pause there. And then from here, we're going to apply this, all right, and see how we can prove these triangles as congruent.